So we want to combine like terms. So remember, in order to be considered like terms, you have to have the same exponent and the same variable. You need to be literally like terms. That means the terms are alike, so you can combine them. You add apples to apples. You don't add apples to bananas. So you want to make sure you have the same variable. So right here we have 6x plus 6 times x plus 3 times x. So these are considered like terms because both of these variable terms have the same variable, which is a x, and both of these x's are raised to the first power. So whenever you have a number, a variable, so we have a variable x, we don't have a exponent here, you can automatically assume that the exponent is 1. So we can combine these because these are like terms. So 6 xylophones, you can think of it as 6 xylophones plus 3 more xylophones is equivalent to 9 xylophones. So that would be the final answer here. The next one, we have 15 times m plus 5 times m. Now you can factor out the m because they are like terms, so you will factor out the m. The plus sign will stay the same in the middle, and then you can put this in parentheses. You can rewrite it at like the distributive property, so you can combine those, that 15 and that 5. So 15 plus 5 is 20, and then you multiply that by m. So you can factor out the variable, and then you can combine the coefficients. Or you could think 15 monkeys plus 5 more monkeys is going to give you 20 monkeys, 20 times m. So the number 3, we have like terms, 3 times x minus 3 times 7. So this is more of a 7th grade standard because we notice that 3 minus 7, 7 is larger than 3, so we can't, well, we can take, we've been told that we cannot take 7 away from 3. You can, you're just going to end up in the negative numbers, which we start learning about negative numbers in 6th grade. So if you have, start with 1, 2, 3, let's draw a number line. So let's start with at 3. So let's go 0, 1, 2, 3. So this is 3. And then with negative 1, negative 2, negative 3, negative 4. All right, so I'm going to start at 3, and then I'm going to take away 7. So I'm going to go in the negative direction, 7 units. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So 3 minus 7 equals negative 4. Or you can say, okay, both of these numbers in absolute value is going to be the absolute value of 3 equals 3. The absolute value of negative 7 equals 7. So I'm going to take the one that's larger in absolute value, which is 7, minus the one that is smaller in absolute value, which is 3. 3 from 7 is 4, and I'm going to keep the sign of the one that's greater in absolute value. So negative 7 is greater in absolute value. So I'm going to say the answer is negative 4. So you would keep the 4 from the difference of the absolute values, which is 4, and the one that's greater in absolute value, since the absolute value of negative 7 is greater than the absolute value of 3, I know that I'm going to keep the negative sign. So, with that being said, we will factor out the x. So we will write 3 minus 7, factor out the x, and then 3 minus 7 is negative 4 times x. And you could keep that in parentheses, but you would eventually multiply it. So that's really the same thing. The next one, we have to make sure we pay attention to our like terms. So we have a constant here, and then we have a constant here. You want to make sure you keep the sign that's in front of the term, in front of the constant, because you have to know what to do with it. So we need to combine 6 minus 4 5/10. We have to make sure we align our decimals and place values when we add and subtract decimals. So since the 6 is in the ones place, the 4 is in the ones place, we must align those two numbers. We need to start with 6 and then take 4 5/10 away from the 6. Do not mix up the terms, because when you're subtracting and when you're dividing, the order is important. So we have to regroup. So we're going to borrow 1 from the 6, and we're sending 10 back to the place value that's smaller. So now we have 10 minus 5, or 5 from 10 is 5. We bring our decimal point down, and 4 from 5 is 1. So I'm going to combine these, and then I'm going to have my variable by itself because I don't have anything to combine terms with. And then this 6 minus 4 and 5/10 is positive, so I'm going to put plus 1 and 5/10. And that is the final answer there. The next one, we have to find our like terms. So I have a constant here, which is a 2, and a constant. Make sure you put the sign that's in front of it. So we have our 2, and then we have our plus 10. So we're going to combine 2 plus 10. Remember to align those decimals and place values. So the 2 is in the ones place, the 0 is in the ones place, so we have to align those. So we have 12. So we're going to have negative t. We bring that down. We don't have anything to combine negative t with. And then once we combine 2 plus 10, we end up with plus 12. So that's our final answer there. The next one, number 6, we have our like term. So we have positive 2 times m plus another m. So we can factor out 2, and remember you can put a 1 in front of there so you can see what's going on. We're going to factor out the m, and this is equivalent because m times 2 is 2 times m, which is what we have there, and then m times 1 is m times 1, which is what we have there. So all I did was I factored out the m, and now I'm going to add 2 plus 1, which is 3, and then that's being multiplied by m, so 3 times m. And then I'm going to bring down my plus 5. Now, usually you write the constant last. So you'll put the variable terms first, the one with the highest exponent first, and then the one with the lower exponents, and then you put the constants last. That's just the way it works with algebra. So this is our final answer, 3 times m plus 5. Moving on to number 7. We have to find our like terms. Remember, in order to be considered like terms, you have to have the same variable and the same exponent. So we have plus 7b minus 5b. So these are our like terms here. If you have 7 bananas and you take away 5 bananas, how many bananas will you have left? And we want to add 3 apples to that. So if you read this expression, thinking about changing the variable into something that you understand, you can say 3 apples plus 7 bananas minus 5 bananas. So you're going to keep the apples separate because they have a different variable, and you're going to put the bananas together. So I'm going to put the bananas together. I'm going to factor out the b. So I have 7 minus 5, and I'm going to put that in parentheses because I'm factoring out the b. And if I were to distribute the b back into the expression, I will multiply 7 times b minus 5 times b. 7 times b minus 7 times b. Minus 5 times b. 7 times b is 7 times b minus 5 times b, which is 5 times b, which is originally what we had. So all I did was I factored out the b. 7 minus 5 equals 2 times b. And then I'm going to bring down, well, it's positive 2 times b. And then I'm going to bring down my 3 times a. And I cannot combine these, so I'm going to leave this like this because these are not like terms because I have a different variable. I have an a, apples, and b, bananas. So these are not like terms because in order to be like terms, you have to have the same variable, same exponent, and clearly a variable is not the same as b variable because they are different letters. The next one, we're going to combine our like terms here, but I noticed that this variable term has an s, this variable term has an x, and this variable term have a k. So since all of the variable terms have different variables, you have to leave it because there are no like terms. So the final answer is 8 times s minus 3 times x plus 4 times k. That's the final answer, and you will leave it as that. Here is the next one. We want to make sure we combine our like terms in order to be considered like terms. Same variable and exponent. So we have x to the second power, or x squared. So these are our only like terms here. And make sure you circle the sign in front of this. So I'm going to factor out the x squared. So I'm going to write 10 minus 15 in parentheses. And I'm going to factor out x squared. 10 minus 15, I'm going to write that. I know that I should end up with a negative number because 10 is smaller than 15. And then I'm going to find out what number I should write on the side. So I'm going to write 15 minus 10. Find the difference of the two numbers, the two absolute value of the two numbers. 15 minus 10 is 5. So I know that 10 minus 15 is going to be negative 5 times x squared. And then I'm going to keep the plus 6 times y and keep the plus 2 times x. And that's my final answer. I cannot combine further here because this variable is x squared, this variable is y, and this variable is x. So right here we have the same variable, but the exponent on this variable is a 2, and the exponent on this variable is a 1. Therefore, you cannot combine these two variable terms because the exponents are different. Same variable, same exponent. Remember that. The next one, we have 10 xylophones plus 5 xylophones is 15 xylophones. But let's factor out the x. So we have 10 plus 5, and we're factoring out the x. So this is equivalent by the distributive property. Now we can combine 10 plus 5, which is 15 times x, and I'm just going to write 15 times x. Then I'm going to bring down the minus 6 times y, and I'm going to leave this because 15 times x and 6 times y are not like terms because the variables are different. Number 11. We're going to combine our like terms. So we have 16 times a minus 7 times a. So I'm going to factor out the a since the a's are the same. The factor that's the same in both. And that's what I want to combine. So I'm going to put 16 minus 7. And I'm factoring out the a. So I'm going to multiply it. Write it as if it's multiplication because I'm factoring it out. And then 16 minus 7 is 9. 9 times 8. And then I'm going to bring down the plus 9. Now you could write this using a distributive property in the greatest common factor. And then you'll factor out a 9, and then you'll write times a plus 1. But that's a whole nother lesson. Anyway, this is the final answer right here. But remember, you can't factor out. But we're just combining like terms for now. This is rewriting using the greatest common factor in the distributive property. This is a lesson we already learned. But you don't need to know this one. Well, you need to know it, but not for this lesson. All right, so the next one, we want to combine our like terms. So our like terms here are 5 2/10 times a minus 8 4/10 times a. So I'm going to factor out the a. I'm going to keep my minus 8 4/10. Put that in parentheses and factor out the a. So on the side, I know that 5 2/10 is smaller than 8 4/10. So I know my answer is going to be a negative number. So over here, I'm going to find the difference between the absolute value of the numbers. So 8 4/10 minus 5 2/10. 2 from 4 is 2. 5 from 8 is 3. So my answer is negative 3 2/10 times A, and I'm going to bring down plus 2 times B, and I'm going to leave it like this because these are not like terms. And this is my final answer right there. Negative 3 2/10 times A plus 2 times B. So remember, in order to be considered like terms, you have to have the same variable and the same exponent. So the same variable, and the same exponent. So this is a 2 and this is a 1. So these are not like terms, so you will leave it as is.